Good afternoon and welcome to this webinar on using PHP 5.3 namespaces. This is a re-recording. We had some technical difficulties with the recording from the live webinar. As a result, there will be no Q&A after this, and also there will be a few differences based on feedback I received on the original webinar. The title claims that there's going to be fame and fortune involved, but really there won't be. It's mainly that it will give you some tools that you can use when using 5.3 in order to organize your code and make it more readable and more semantic. My name is Matthew Wirofini. I'm project lead for Zen Framework. Part of the reason I'm doing this webinar is because with Zen Framework 2.0, we've been working on a number of initiatives, and the first initiative we accomplished was converting our entire code base to using namespaces. As such, I think I have some unique perspectives on some ideas that you can use with code organization with namespaces, and also some tips and tricks that we have discovered and some pitfalls that we've also fallen into. So what are namespaces exactly? The PHP manual tells us it's a way in which to group related classes, functions, and constants. Really, that's not very helpful. So let's look at the basics here. First off, I'm going to go into something controversial, and that's the namespace separator. And my advice to you is simply get over it. There's been a ton of bike shedding over this on the last few years. There was bike shedding before 5.3 was released. It was basically ongoing practically to the day that they triggered it. And now, almost 2 years later, you still have people complaining about the namespace separator. Let's be honest, PHP has a lot of ugliness in it, and namespace separator is just one of those things that you might consider ugly. The fact of the matter is you can simply use it. It's a tool. Type a single character, and now you're able to have a separation of different namespaces within your code. In practice, you're not going to be typing it at all that often. As I will recommend later, you're typically going to be typing the namespace at the top of your file and your imports at the top of your file, and from there on you won't be utilizing it anywhere else in your code. There will be occasions, but it's not like you're typing it on every single line. It's a single character. It's one that's usually fairly easy to find on your keyboard and doesn't require a whole lot of muscle memory in order to find. Just get over it and start using it. Now, getting back to the main topic, what can live in namespaces? Classes, constants, and functions. So we'll take a look at each of these, but let's start with the very basics, and that is, how do you declare a namespace? The most basic is a single line declaration. I'm using here a namespace of Zend. Notice there are no quotes, and notice I'm simply terminating the line with a semicolon. It's really that easy. Now that I've done this, all code that follows is within that namespace. You can also use what's called a block declaration. A block declaration is just like a class declaration, if then else, function declaration, while statements, that sort of thing. Those are all considered block declarations, and in this case you can do a declaration using the block style. So namespace send, and then your opening blocks. Namespace fly, your opening blocks. Everything within the braces then is considered within that particular namespace. This is the way that the PHP manual recommends declaring namespaces if you'll use more than one namespace per file. Typically you will not, but if you want to, this is how you would do it. Now, namespaces by themselves are really not all that useful. In fact, if you try and import just a top-level namespace like we've had before, it's going to give you some sort of warning saying, hey, this really has no semantic meaning to me. So what really has meaning are what are called sub-namespaces, and this is where that dreaded namespace separator comes into play. And I say dreaded, I actually don't mind it. The sub-namespace concept is basically that you can nest namespaces. And you do so by simply utilizing the namespace separator to separate the various levels of the hierarchy with your namespaces. So we have Zendlog here and Zendlog Writer. So Writer is a subnamespace of Zendlog, and log itself is a subnamespace of Zend. Now, when you refer to namespaced elements from non-namespaced code, you simply type them the full name, just like you would with the pseudo namespaced code that you're used to with a Zen framework or pair or any code base that follows pair naming conventions. Instead of the underscore that you utilize with those, it's going to be the actual namespace separator here, the backslash. So we have class new my registry, class my log logger. We're referring to a function called my stir split. This is where we get some interesting stuff later. And val is my API key. Convention with constants is that you utilize all uppercase. This makes it clear where the constant exists within the actual namespace string. Now, if you are within a namespace and you're referring to other elements that exist within that namespace, you can actually omit that prefix. So here we're within the namespace my. So this is the exact same example as the previous slide, but because we're within the namespace mine, I don't have to prefix everything with a my backslash. So just new registry, new log logger. Stir split, ooh, this is an interesting one. We'll get back to that in a little bit. And val equals API key, getting a constant value. Now, if you are in a different namespace, so for instance you're in your namespace, and you want to utilize those things that are in other namespaces, you need to globally qualify them. So to do that, you simply do the leading backslash, and this is basically saying I want to resolve this from the global namespace, which is a backslash. You don't normally have to utilize the backslash when you're in the global namespace itself, but within other namespace code you do. So backslash my, backslash registry, my log logger, my stir split. So notice in each of these examples, they're prefixed with a leading namespace separator. Now, if you're like me, that looks really ugly. And we're going to go into some examples of how to make that shorter in a moment. But what's really interesting is how namespaced elements resolve. And this is going to go back to that stir split idea in a moment here. So prefixing with the namespace separator always resolves to what's called a fully qualified name, or a globally qualified name. Now the resolution order is, if it's globally qualified, we know it, so we're just going to go ahead and use it. It's already resolved. Otherwise, we're going to try and resolve it against the current namespace, or relative to it. So any of the items, classes, functions, constants, if it finds it in the current namespace, then it will go ahead and utilize it. Then, if it still can't find it, for functions and constants, it will then look in the global namespace. So what this means is that classes always have to be fully qualified somehow. They either need to be relative to the current namespace, or they have to be globally qualified using that prefix of the namespace separator and then the actual namespace that the code lives in. Now, functions and constants, however, do not need to do this, which means that you can do something fun here. You can actually override system functions with namespaces within your namespace. So say for instance we're in my namespace and I define the function stir split. This is an actual system function and I'm actually using the same signature, but I'm doing something slightly different. I'm going to split on the word character instead of split based on the length of the split length. So what this means is when I'm within my namespace, anytime I call stir split, without globally qualifying it, it's going to utilize this new function I've done here. Some liken this to monkey patching in Ruby. It's not really the same thing, but the whole point here is that you can override the system functions within your namespaces, which gives you a lot of flexibility if you discover some behavior that you need to fix or patch, or somehow override slightly in order to accomplish a task. Now I mentioned before that when you're referring to a namespace code from another namespace, it really looks pretty ugly and it really looks no different than what we've seen in 5.2 and previous. Where it becomes really interesting though is when you import namespaces. Importing is simply a way to bring code from another namespace into the current namespace. You can import classes or you can import other namespaces. You can't import, you can also import functions, and I believe constants as well, but typically what you'll see are importing classes and namespaces. Importing uses the keyword use. As an example here, we have a namespace my with a class of registry. In namespace your, you can use my, which is going to import the namespace, or you can use my registry to import the class. Very easy. Now utilizing that imported code, again, we have a namespace your, we're going to use my, which is going to import the namespace. Now our registry can now be retrieved saying new my registry. Okay, we've saved one character. Next example here is namespace your and use my registry, which will import the class registry out of the namespace my. If we now can just simply say new registry, and that's a lot cleaner and simpler. I like that. Now we can make it even more interesting using a feature called aliasing. With aliasing, you're going to import a namespace or a class, but you're going to refer to it using a different name. To do this, we utilize the as keyword. So in namespace your, we're going to use my as m. So now we can say new m\registry. Or use my registry as reg. So I can now say $r equals new reg. That's pretty nice. It's not a great example, but it gives you an idea of what you're able to do. A common use case I've had for this, believe it or not, is utilizing pseudo namespaces from 5.2 and before within 5.3. And what I'll do is something such as use Zend controller action as action controller. And what this will do is it will import that class, and I can now refer to it as simply action controller within my code. This is a very useful technique. As an example, you can make things more semantic using aliasing. So consider I'm in the namespace app and I want to use the new event manager from Zen Framework 2. I can import that using the use keyword and alias it using the as keyword. Use Zen event manager. This is the component name. Event manager is the class, but I'm going to use it as events. So now within my class foo, I will refer to the class as simply events. And you can see the examples with the events in the type hint for the function, as well as being used an instance of in a couple of places. Also, we instantiate a new instance of events if none is found within the class on the first call. You can also import multiple namespaces or classes. So to do this, you do multiple use statements. So I'm in namespace there. I'm going to use my and use your. Now, having a bunch of use statements like that, I find clutters things, and it's hard to tell where the use statements stop. So there's an alternate syntax, and that is to use a comma to separate the statements. So I can say use my, comma, your, and it will import both of those namespaces. I can also use this with aliasing. Use my as m and your. Very simple. Now, at some point you may want to know what namespace you're actually in. A good example is, for instance, with factories, you may want to refer to a short name such as MySQL in order to load up an adapter. So you might be in the MyDB namespace, so you could say underscore underscore namespace underscore underscore dot adapter slash mysql.php, and you'd be able to figure out the namespace that you're utilizing. As a more comprehensive example, let's take a look at this setup. We've got a namespace my\package and also another namespace my\other package. Each of these defines three things: a constant API key, a function get, and a class service. Now, in our example here, we utilize the namespace test. And we're going to use my package service as package service. So we're aliasing the service class from the my package namespace to the class name package service. We're also importing my namespace other package. So this is the other package subnamespace of my. We'll declare a constant API key within this namespace of test as well. If we echo that, we're going to get 3 because that's what we defined. If we echo other package API key, we'll get 2. And if we globally qualify with a my package API key, we'll get 1. Makes sense. Now, if I want to instantiate a service, I can say new package service, which will resolve to my package service. If I now say new service, it doesn't know what to do with this. We haven't declared a service class within this current namespace, and so it can't find it. If I say other package service, that is going to say, hey, I have imported the my other package namespace currently, so let's resolve service to that, and it's able to find it. Now, if I try to call get, I'm going to get an efatal here. There's no matching function in the current namespace, but other package get will find it. So those are just a few examples of showing how resolution works and how you can mix and match. There's obviously other things I could do differently, but the point is to show you the ideas of grabbing something from the current namespace, grabbing something from an aliased or imported namespace, and grabbing something globally. And you can see all those examples right here. Now, no technology is without its pitfalls. I can't think of any technology that doesn't have pitfalls. And namespaces are certainly prone to their own. So you can reference namespace code within strings. The problem here is that classes, constants, and functions referenced in a string have to be fully qualified. You don't need to prefix with a namespace separator to fully qualify them. They're just assumed to be fully qualified. So let's give an example. We're in namespace my, and there's a log subnamespace with a logger class within this namespace. If I say class equals log logger, you would expect that that would probably resolve if I tried to instantiate it. However, it says, hey, there's no log namespace with the logger class. And you immediately go, what? Of course I have, because you're looking at my namespace my. But the PHP engine says, no, it doesn't exist. So the next thing you can do is you can say my /log /logger. So fully qualify it, except for don't use the namespace prefix at the beginning. That's a success. You can also use the namespace prefix, but it's not necessary. I find that if I just omit it from the beginning, it's perfectly fine, and it makes it a little bit easier on my fingers as well as I'm typing. This is also true when you do tests such as instance of or type hinting. It has to be, if you're using a string to provide the name of the class that you want to type hint against, you have to fully qualify it. So if we capture class $class as a variable as log logger, it will not qualify here, but capturing it as my log logger will. So just be aware of this when you use namespaces. If you are referring to a namespaced element within a string, it needs to be fully qualified. So we've seen a number of examples. The big question is, why do we want to use namespaces in the first place? First off, for those of you familiar with the pair coding standards, or if you've used Zen Framework, which also adopts pair coding standards, we've had this concept of one class per file and a one-to-one relationship of the class name to the file system name. Now the class name utilizes underscores to separate the various segments, and everywhere there's an underscore, that translates to a directory separator. It's not terribly semantic in terms of, I look at the underscore, I'm not necessarily going to think, oh, that's a directory separator. An underscore is a perfectly valid character within most file systems. However, when we look at namespaces, the namespace separator, love it or loathe it, either way, it has an affinity for the directory separator. Within Windows, it is the directory separator. Within Linux, Mac, Unix, all those, basically same file systems, you have the slash being your directory separator. Either way, it looks similar. So it automatically suggests a one-to-one relationship with the file system. If I have a namespace of my log and a class of logger, I think about the fully qualified name here as my log logger, and I would expect to find it in my /log/logger.php. That's something that I can look at and instantly grok. There's also the idea of code organization by responsibility. In particular, I want to look at interfaces. In the use case of using instance of or implements, it's useful to have a name that is descriptive of the capabilities. So if I say class instance of adapter, I can understand, hey, I'm testing to see if this object instance I have is an instance of an adapter. Or if I say some class implements adapter, it's also again very clear. I'm declaring a class that is an adapter. It's natural language. Natural language is very easy to understand. I'm also going to suggest that in this case, natural language is going to suggest a hierarchy for us. I can have a namespace of translator adapter, and I can also have an interface called translator adapter that I'm going to import, which gives me the capability of saying class concrete adapter implements adapter. The interface, translator adapter, is going to be in translator adapter.php, and then this concrete class will be in translator adapter concrete adapter.php. So I have this idea now where I have some sort of interface to which a whole bunch of things are going to adhere, and I can look at the file system and figure out what they are, and I know where to look for them. Basically, I'm referencing the capabilities of my code and not the language type. It's not an interface. I'm not thinking about it, is it an interface? I'm thinking what capabilities does it provide? So this gives me, along with the one-to-one translation of the namespace separator to the directory separator, these things together allow me to provide and think of a nice discrete hierarchy within my file system. The next thing, of course, and this is the one that everybody really wanted namespaces for, was readability. So within a namespace, you can reference the class names directly and keep the usage succinct. If I'm in Zen Search Lucene, I don't want to be referencing Zen Search Lucene at the beginning of all of my class names. Same thing with send HTTP, which is what I used here. If I'm in the namespace send HTTP, I can simply use new client. And I'm done. I know what I'm doing. With importing and aliasing, I can make names succinct even when I'm not in that same namespace. So for instance, namespace of application, I can use send HTTP client as HTTP client and send logger logger, or send log logger actually in this case. New HTTP client, new logger. When I look at the code itself, the code where I'm actually utilizing the classes, it becomes much more succinct. I do have these use statements at the top of the file, but I think of those more as a map. Okay, when I encounter this, it means this. And typically, the semantic meaning is enough for me to understand what it is and how I operate on it. So new logger is much easier than Zend log logger. HTTP client is easier than Zend HTTP client with a bunch of punctuation and whatnot in between the various segments. I can just refer to what they are. I can also use aliasing to give context. So I used this example earlier only with 5.2 code, but use Zen controller action as action controller. So class foo controller extends action controller. That's really easy. It's much easier than extends Zen controller action or extends action. Those don't have a lot of context, but the context of action controller tells me what type this is. Last but not least, dependency declarations. One of the problems that people typically have with their applications is how do I identify all the classes I'm using within my code in order to make sure that they get up to the production environment. Now, a lot of us are simply taking the entire code base and tarballing it and setting it up, or using FTP or SSH or whatever. But another possibility is you use a tool like Fing or Ant or some other tool that's going to go and package up your files and send them somewhere. I would suggest that you should import every class outside the current namespace that you consume at the top of your file. So for instance, if I am in the namespace application controller, I might import Zen controller action, my data mapper, maybe a blog entry class, which is a service, rather an entity class, and maybe an event manager. These are all the different classes or object types that I'm going to consume within this particular class. Then when I go to deploy, I can actually run a tool that does static analysis on this particular file, takes a look at the use statement and says, okay, these are the components I need, and make sure that all of those components are available within the package that I create. You may say, well, that seems like it's a lot of effort to do all that at the beginning, and well, what happens with PHP? Well, the fact is that imports are simply hints to the interpreter. It creates a memory map of what the different aliases are and what class they actually refer to. They basically don't cost you anything, not in performance, really not much in RAM at all. It also helps you to document your dependencies up front, and like I said, you can do static analysis on this later in order to determine what all your dependencies are. So you have nothing to lose and a whole bunch of stuff to gain by adopting this one simple practice. And it's a practice that namespaces have given us. It's not something we could have easily done before. We could have done require onces and all that sort of thing. But the require onces are a little bit harder, and you have all sorts of issues with names, with the resolution and all of that stuff. Whereas this is just simply code semantic level, what are my dependencies? And you can figure out where those actually reside some other way, perhaps a class map or some other tool. So the main resource that you have for this is the PHP manual, php.net/namespace. And this is really got the most comprehensive information possible out there. You can get some of the tips and tricks, such as I presented in here, from various blog posts, but a lot of them are actually suggested within the manual itself. Hopefully I've answered your questions about PHP 5.3 namespaces, and I hope you'll join me again in a future webinar. Thank you.